Welcome back, everyone, to another random installment of Introduction to Insect Taxonomy. Today, I wanted to talk about an order of insects which is extinct. And the order I wanted to talk about are the Palaeodictyoptera. So, this is a now extinct, very ancient insect order that we only know from fossils, and the fossils aren't great. So, we have to make some educated guesses from what we do have. And one of the problems, or actually multiple problems, that exist with talking about extinct insects is insects don't generally leave behind very good fossils. And there's a couple reasons for that. One, insects, because they're invertebrates, don't have good, heavily mineralized body parts like you would find in vertebrates. So there's no bones. There are no bones to fossilize. So you're basically left with hoping to fossilize the exoskeleton and the wings. The issue with that is that because they are primarily terrestrial, there isn't a good chance of them being covered by sediment. So things that are in the marine environment, so like trilobites and crustaceans and things like that, those invertebrates do tend to leave behind more fossils because there is a pretty good chance that they will be randomly encased in sediment. So we frequently find large collections of trilobites kind of all preserved together in the same spot because presumably they were going about their life and then they got caught in like a mudslide or a landslide underwater, and all that sediment just instantly buried them. Same with things like crabs that will fall to the bottom of an ocean or something like that and then get covered in the very loose sediment on the bottom of the ocean. For the terrestrial environment, that doesn't tend to happen very often. So now we're left with no bones and a low likelihood of getting covered by sediment. So the majority of insects that we talk about in the fossil record, I shouldn't say the majority, but a lot of the fossils that we talk about with insects are insects that have been preserved in amber. Unfortunately, a lot of these insects, these Palaeodictyoptera, are very, very large. So they are not going to likely be, preserved whole cloth in amber. I say whole cloth, whole body in amber. Although there are some amber fossils of this, there's just, issues with getting insect fossils. So you have to be pretty happy with the ones that you do manage to find. The Palaeodictyoptera, where would they fall in our phylogenetic tree? So we have, the pre-insects and the ancient wingless insects. The Palaeodictyoptera had wings. So they are, around this area. They're ancient insects. They likely are, here between the Odonata and the Plecoptera in the insect tree of life. What we know about them, so again, this is a different phylogenetic tree, but we have the Archaeonatha and the Zygentoma, so like the firebrats and the silverfish, the Panephemeroptera, so these are all of the mayflies, the Odonatoptera, which are the all of the dragonflies throughout history, and the Palaeodictyoptera is somewhere in the middle up here. And this is a drawing down here of one. This guy right here is the Palaeodictyopteran. And they are a very strange group. They are kind of in the middle point of where insects began to develop a hinge mechanism for being able to fold their wings over their back. A lot of the Palaeodictyoptera can't fold their wings over their back, but their cousins can. So you're in this middle point between like the modern mayflies and dragonflies, which can't fold their wings, and stoneflies, which can. So they likely are in that area in between. What's cool about the Palaeodictyoptera as an order is that you'll see here, they actually have an extra set of wings. So unlike modern insects, which only have two pairs of wings, the Palaeodictyoptera have three pairs of wings, so they have six. Really, really neat. They have very trilobite-like nymphs, which I'll talk about in a bit. But they're a very, very strange insect order, and they tended to be fairly large. We do have smaller sample or smaller sized versions of them, but they are some of the largest insects that ever existed. Other things that you should know about this group. So the Palaeodictyoptera, the name means paleo, meaning ancient, and then Dictyoptera, meaning net wings. There is another group of insects which are sometimes referred to as the Dictyoptera, and it is this group here, the Isoptera, the Platodia, and the Mantodia. These are sometimes referred to as the Dictyoptera, which means netwings. So the Palaeodictyoptera are the ancient netwings, and they do kind of, again, occur in this area here, right above them in the tree of life for the insects. So what time period are we talking about? So if you're not used to seeing a geological timescale graphic, MA is millions of years ago. So, at the top of this graph is modern age, and then you begin going backwards in time. So we're past the modern age. 65 million years ago, this is the extinction of the dinosaurs. So this area here is the Cretaceous, the KT boundary, the Cretaceous Tertiary boundary. Boundary right here is the beginning of the dinosaurs. So every little kid will be able to tell you the Triassic, Jurassic, and the Cretaceous. This is the age of the dinosaurs. And the dinosaurs arose after the Permian extinction. So the Permian Triassic extinction is another extinction. And that is the extinction which drove the Palaeodictyoptera to death. So the Palaeodictyoptera arose during the Carboniferous period, which is here listed as the Mississippian and the Pennsylvanian. And they likely arose here in the late Mississippian, and then they went extinct here at the Permian extinction. So between 318 and 251 million years ago is when these guys lived. So very ancient, and they're one of the first, giant winged insects. So what can we glean from the fossils of the Palaeodictyoptera that we can kind of infer from what we do have, right? So all Palaeodictyoptera, I shouldn't say all, but a lot of them have been found in the Northern Hemisphere, and these are in the coal swamps of the Northern Hemisphere where we do manage to find some of their fossils. So they were associated with these sorts of gymnosperm trees. They all had complex wing venation. So I do have a picture here of one of their fossils. This is one of their wings, and this is how they got the name netwings. So they have this extremely dense vein network, both running out and across. So this way denser than what we see in normal modern day insects, way denser than what we see in like the mayflies or the odonates. So very, very primitive sorts of wing structures. Generally, we associate heavy venation with a primitive wing structure. Interestingly, these guys seemed to have piercing, sucking mouthparts. So unlike the dragonflies, which have chewing mouthparts, these seem to be some of the earliest insects with piercing, sucking mouthparts. They had 5 stylets, presumably to feed on plant material, so sucking sap out of plants, but presumably some of them would have also been predators. This is what we see in the modern hemipterans. A lot of them are plant feeders, but things like the assassin bugs are also predators. And then you also get some ectoparasites within the group. They had very large compound eyes. They had very large antennae. And then what I mentioned earlier, the Palaeodictyoptera seem to have this third, this is the order with this third set of wings. And the wings are coming off of the pronotum, which is right here. So, or I don't know if you would still call it a pronotum in this case because it's so early, but the first thoracic segment seems to have wings, or of these sort of winglets. They're wings, but they're much smaller than the main flying wings. In most species, the wings have to remain outstretched. They are not capable of folding them behind them. They have cerci, and the females will have a long ovipositor which had saw-like teeth on it, which would presumably been used for sawing into plants in order to lay eggs within the plant tissue. The Palaeodictyoptera ranged kind of wildly in size. We have some of these smaller fossils. So if I zoom out here, you can see that this is a smaller rock with a smaller fossil. But they also had some of the largest insects known in history, reaching up to 2 feet long in wingspan. So just absolutely enormous. I'm sure you've seen those pictures of the giant dragonflies. These were comparable. The nymphs are really interesting. And we have a fossil of a nymph down here. This here is a nymph of a Palaeodictyoptera. They were kind of trilobite shaped. And one of the interesting things that they have in this fossil are these are the wing pads of the nymph. So the head would be so this would be another wing pad. The head would be attached up here. They had these sort of bizarre wing pads, which are not seen in modern insects. In modern insects, the wing pads tend to be on the back or they tend to be folded in on the back. On the Palaeodictyoptera, the wing pads are to the side. They are oblique to the body axis, and they also tend to be fused to the side of the body. This is a very strange method of development compared to all modern insects. Why they do that, I don't know, but this isn't a feature that you see in any modern species. Presumably, the nymphs were primarily terrestrial, although some do show some adaptations for aquatic life. So if we go down here, you can see kind of an artist's interpretation of what a Palaeodictyoptera nymph would have looked like. It has these oblique wing pads coming off the side of the body, as opposed to being fused along the back of the body. So we can tell a few other, most of this is derived from just a handful of fossils and amber specimens, but this is what we think that the adults would have looked like in most cases, where you have these large piercing sucking mouthparts attached to the front of the body to feed on trees and the like, or there have been apparently some seeds found with fossilized seeds found with some damage that looks like it could have come from these mouthparts. You have 3 sets of wings, which is very, very odd. The wings develop obliquely to the side of the body, very large abdomen that seems to be largely unspecialized, long cerci, long antennae. The females would have had long ovipositors, and then a very bizarre trilobite-like nymph. This is the same sort of body plan, but from the side. This is frequently what you would find in a laterally pressed fossil. So you have the wing pads coming off the side of the body. Very, very strange creatures overall. Unfortunately, all extinct now, but cool to think about. So that is your first introduction to extinct insects. I would like to talk about more extinct insects mainly because I like learning about them. So I'll come up with another group to talk about, and I'll talk to you guys later.